Well, we'll continue on here. We'll look at this. We'll put in infinity. We get infinity times. You put infinity here over infinity here, which is 0 almost, and the natural log of something almost 0 is once again an indeterminate form. However, we can't go ahead and use L'Hopital's rule to begin with because it's not written as a fraction. So I'm going to just take my natural log here, but instead of multiplying by x, I'm going to divide by 1 over x because you can divide by the reciprocal. Now on top you have the natural log of two things divided, so you can take the natural log of the first one minus natural log of the second one. Now it's written as a quotient, so it's pretty easy to go ahead and apply L'Hopital's rule. You go ahead and take the derivative of the top, 1 over my, oh, I see we got a mistake here. That's a minus sign. Minus 1 over the second one. Take the derivative of the bottom. It's in x to the negative 1. Take your derivative. So now we can go ahead and simplify the top, do a common denominator. So the top simplifies down to just a 2 over an x squared minus 1. The bottom is a negative 1 over an x squared. So we have a fraction divided by a fraction, so we multiply by the reciprocal. So we get this. Now, basically all you have to do is look at most influential over most influential because we're looking at our limit going to infinity, and we end up getting negative 2. Now, technically speaking, you should apply L'Hopital's rule to the top and the bottom. Then you have to do it an additional time before you will get your negative 2 showing up. Well, here we want to plug in 0. Get 1 over 0, which is undefined, minus 1 over 0, which is, for the most part, infinity minus infinity. Now, we cannot use L'Hopital's rule because it's not as a quotient. So you got to do a common denominator, multiply top and bottom of the first one by a sine x, the next one by an x. And so write it as a fraction, a single quotient, before you can use L'Hopital's rule. Now we could try plugging in 0. You get 0 minus 0, which is 0, over 0 times 0, which is 0, still an indeterminate form, so now we can go ahead and use L'Hopital's rule. And we'll do derivative of the top, derivative of sine, you know, is your cosine. Derivative of your x is your 1. On the bottom, you got to use product rule. Derivative of the first is x times the second, plus the first, which is x, times the derivative of the second. Now we can go ahead and plug in 0. Plug in 0 here. Cosine of 0 is 1. 1 minus 1 is 0. Plug in 0 here, sine of 0 is 0. Plug in 0 here, it'd be 0 times 1, which is 0. So on the bottom, we get 0 plus 0, or 0. Well, we got another indeterminate form, so we use L'Hopital's rule. Again, derivative of the top, negative sine. Derivative of this, cosine. Then you have to use product rule here. Derivative of the first is 1 times your cosine, plus the first times the derivative of the second, and derivative of cosine is negative sine, so that's why there's a negative sign here. So we end up then with a couple of cosines on the bottom. Your cosine plus cosine is your 2 cosine. Now we could try plugging in 0. Sine of 0 is 0. Cosine of 0 is 1 times 2 is 2. Minus, and then you're going to get 0. So you get 2 minus 0 on the bottom. 0 over 2 is 0. Now, if you're trying to take a limit of an expression raised to a power, where you have a variable up there, you're going to want to go ahead and use logarithms to help you out. Basically, you're going to take the natural log of each side, take your exponent, put it down in front of your log, work it out using L'Hopital's rule, and then just at the end have to remember to undo your log. So here we have an expression raised to a power. If we would go ahead and plug in 0, we get 0. Oh, sorry, cosine of 0 is 1. You get 1 to the plug in 0 here. It'd really be infinity. 1 to the 0, or 1 to the 0, sorry. 1 to the infinity is undefined, or in indeterminate form, so we can use L'Hospital's rule. So we're going to say y is equal to our expression that we had. We're going to apply a natural log then to work this out, because we can't easily write this as a quotient without using our logs. Now, all we're going to do is take our exponent here, put it down in front of our log. Now, this can be then written as a quotient. So now that we have it written as a quotient, and remember, we're trying to go ahead and take our limit of this. So I now need to apply my limit to the left side, apply my limit to the right side. Now, looking at the right side, the limit of a fraction, let's see what we get when we plug in our 0. And well, in this case, it ends up being an indeterminate form again. Since the right side's a limit, and it's a fraction, and it's an indeterminate form, we can use L'Hospital's rule. So I'm going to just go ahead and bring down the left side, not really do much with the left side. So I'm going to do the derivative of the top, so it'd be 1 over cosine, times the derivative of the inside. Derivative of cosine is your negative sign. Derivative of the bottom. So it's really a negative tangent over 2x. Now I could try plugging in 0. You get 0 on top, 0 on the bottom. So once again, I can use L'Hospital's rule again. Derivative of a tangent, you know, is a secant squared. You have your negative in front. Derivative of the bottom is 2. So as we look here, we try to plug in 0. Remember, that's the reciprocal of cosine. Cosine of 0 is 1. The reciprocal of that is 1. Square that is 1 times a negative. So we get a negative 1 on top, get a 2 on the bottom. Now you might be wondering, well, how did the left side here simplify down to this? Well, here you're looking at your limit as x approaches 0. Well, do you have any x's in your expression? No, so x has no effect on it, so it's really just natural log of y. Well, now you got to think, okay, this is really log base e of y is equal to the negative 1/2. So all we're going to do is Tarzan this, take our e and swing it over, and then that tells us what our y is. So we get e to the negative 1/2. On this one here, we have a variable raised to a variable. Try plugging in 0. You get 0 raised to the 0, which is an indeterminate form. Since it's a variable to a variable, you're going to want to use log, so you set y equal to it. Apply a log to each side. Take what's after your log, put it down in front. Now you got to write this as a quotient, so you want to go ahead and divide. So it's really natural log over your cotangent. Now we're dealing with our limit here, so you got to put the limit in on front of each side. Try taking and plugging in 0 here. Well, then you end up getting a negative infinity over infinity, which is an indeterminate form. So now that it's written as a quotient and it's an indeterminate form, we can use L'Hospital's rule. So we take the derivative of the top over the derivative of the bottom, and simplifies down to this, because that's 1 over sine squared, so a fraction over a fraction. Now we can try plugging in our 0. Oh, sorry about that. Now our sine squared is really a sine times a sine. So I'm going to write it as a sine x over an x times your negative sine over 1. This right here is your basic trig limit. You know that that basic trig limit is your 1. Over here, you just got the sine of negative x. You plug in your 0 into the sine of negative x. Sine of 0 is 0. So you get your limit then to be 0. Once again, on the left side, the limit of your x approaches 0 doesn't do anything to your y stuff. Then you want to Tarzan, take your e over to the 0, and you get 1.